Hello everyone, welcome back to my channel. My name is Antonio G. Tolosa. So for this day, we will do the activity in chapter 8. But before that, we need to read the introduction of this chapter. Okay, we go to the introduction. So chapter 8, Subnetting IP Network. So designing, implementing, and managing an effective IP addressing plan ensure that network can operate effectively and efficiently. This is especially true as the number of hosts connection to a network increases. Understanding the hierarchical structure of the IP address and how to modify that hierarchy in order to more efficiently meet routing requirement is an important part of planning an IP addressing scheme. In the original IP version for address, there are two levels of hierarchy, a network and a host. These two levels of addressing allow for basic network grouping that facilitate in routing packets to a destination network. A router forwards packet based on the network portion of IP address. So when the network is located, the host portion of the address allow for identification of the destination device. However, as network grow with many organizations adding hundreds and even thousands of hosts to their network, the two-level hierarchy is insufficient. Subdividing a network adds a level to the network hierarchy, creating in essence three levels: a network, a subnetwork, and a host. Introducing an additional level to the hierarchy creates additional subgroup within an IP network that facilitate faster packet delivery and added filtration by helping to minimize local traffic. So this chapter examines in details the creation and assignment of IP network and subnetwork addresses through the use of subnet mask. Okay, so we are done into the introduction of this chapter. So we go to the activity of of this chapter. So we need to find it. Okay, this activity. So the title of this activity is calculate the subnet mask. So the instruction of this is, so in this activity you are given a subnet mask in decimal format. Enter the binary representation of the subnet mask in the octet field provided. Additionally, convert the mask to prefix notation format in the prefix notation field. Okay, so it is very easy. So the subnet mask here is 255, 255, 255, and 240. So 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 255 is, so what we call that. So the subnet mask 255 we will convert it into binary by 1111111 octet. So because 128, because this binary consists of 1, 2, 4, 8, 30, 16, 32, 64, and 128. And and it is equivalent to 255. Then it will be 11111 here, then 11111 here, and 240. So 128 plus 128 plus 64 is 192, plus 32 equals 224, then plus 16 equals 240. So the remaining will be 0. So what is the prefix notation? So we will add it. 8 plus 8 equals 16 plus 8 equals 24 plus 24, 25, 26, 27, 28. So the prefix notation is slash 28. Okay, so we are correct. Then we go to another example. So the subnet mask here is 255, 255, 254, and 0. So it will be 1111, then it will be 111111, then 254. So 128 plus 64 equals 192 plus 32 equals 224 plus 16 equals 240 plus 8 equals 252 plus 2 2 plus 4 equals ay 248 pala plus 4 equals 252 plus 2 is 254 and 254. So it will be 0 here. Then it's all 0. So what is the prefix notation? So 8 plus 8 equals 16 plus 17, 18, 19, 20, 22, 23. So it will be 23. 23. Correct. So we are done in this activity. So we go to another activity. So the title of this activity is determine the number of bits to borrow. So the instruction of this activity is you are given the number of hosts that are needed. Determine the subnet mask that would support the number of hosts as specified. Enter your answer in binary, decimal, and prefix notation format in the field provided. Okay. So the host needed here is 25. So sub the subnet mask here, so it will be converted to binary. So it will be 11111 here, 111111, 111111, then 111 and 000. So it is the binary of the subnet mask. Then we will convert it to decimal. So it will be 255, oh sorry, 255.255.255.244 to no 0.224 slash 27. Okay, so I will write it before I explain it. 1 1 1 1 1 1 1 0 0, then 0 0 0 here, then it will be 252 slash 22. So okay, before I already answered it, that's why the answer is appearing in the box. Okay, then 0 254, and so we'll check it if it's correct also. So I will discuss this. So this is the subnet mask of the subnet mask that converted to binary. Then it is the subnet mask that is converted to decimal. Then so why it is 224? Because 128 plus 64 plus 32 equals 224. So and the prefix notation is /27 because 8 plus 8 plus 8 equals 24 plus 1, 2, 3 equals 27. Then why the subnet mask is 252 here? Because one wait what we call 128 plus 64 equals 192 plus 32 equals 224 plus 16 equals 240 plus 8 equals 248 and plus 4 equals 252. So why it is /22? Because 8 plus 8 equals 16, 17, 18, 19, 20, 21, 22. So the remaining one, that's why it will be 22. Okay. So and so on. So ganun lang po yung paggagawa nito. So we go to another activity here. So in 8.1.5, so this activity, so the title of this activity is practicing VLSM, or the variable length subnet mask, masking or mask, what we call. So the instruction of this activity is table 1 uses regular subnetting to accommodate the network shown. Table 2 uses VLSM to further subnet the network. Drag the addresses to the appropriate subnet description. So the network ID used here is 192.168.5.0/24. So the host here is 50. So calculate 50 user per subnet. So 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 they want to find the new subnet mask that is converted to decimal, then the first prefix notation, the first full subnet range, the second full subnet range, and the last full subnet range. So 168.5. So I write the network ID is 192.168.5.0/24. So this is the /24. So this is the network ID. Okay. Network ID. So first we need to so the step 1, then wait and it's 50 hosts. So first we need to know or determine the default subnet mask. So step 1 determine the default subnet mask. So 192. So this is the default address classes. So it composed of class A, class B, and class C. So class A is, so the characteristic of class A is the first octet range is 1 to 126. Then the default mask is 255.0.0.0. Then the default host per network is 16.777 and 216. Then class B, so the first octet range is 128 to 191. Then the default mask is 255.255.0.0. Then the default host per network is 1048 and 576. Then the class C, so the first octet range is 192 to 223. Then the default mask is 255.255.255.0. Then the default host per network is 254. So we go to step 1, determine the default subnet mask. So it is 192 here. So the first octet range is 192. So this network ID are in class C. So the default mask that we will use is 255 255.255.0. We need to copy here. So this is the default subnet mask. So we go to step 2. Step 2, break the available bits. So by doing that, we need to convert the subnet mask into binary. Okay. So 255 will convert to 1111111 8 octet 2468, then 8 octet 2468, then 1 2 3 4 5 6 7 8, and 0 will be 0000000 2468. Okay. So next we will find the 50 hosts. We will find a number that will be equal to 50. So we will use this host. Okay, because 1 is representing the subnet bits, while the 0 is representing the host bit. Okay, so we will get it in back. That's why we can easily know. So okay, so it can 50, that can, so find a number that can equal to 50. So it will be 32. Then 32 plus 16 is not 50. 32 plus 15 16. Wait, 32 plus 16. So 32 plus 16 equals 48. Then it will be plus 8 equals not 50, plus 4 is not 50. Then 48 plus 2 equals 50. Then it will be 0. So we can, so 1 2 3 4 5 6. So we have a 6-bit here. Then next, what we'll do next? Going to submit figure out. So we will determine the news. So the new subnet mask will be the new subnet mask will be, okay, we need to will be this be point. So 1 2 3 4 5 6. So this 6 bit will be a host, that's why, so it will be 0, then the remaining bits will be in subnet bits, that will be 1. So it will be, wait, so it will be, convert as 1 1 2 2 0 0 0 2 4 8. Then it will be the new subnet mask. So we will convert it to decimal. So it will be 255.255.255.255.192, no, 190 192 plus 128 plus 64 equals 192. 192 slash 26. Okay, so let's find if it is correct. Okay, so the new subnet mask will be 19255.255.255.192. Then the first prefix notation will be 26. Okay, so next is next step is figure out the new network address, network IDs. So by doing that, we will, we will copy this, then view, then so this subnet mask will subtract to 256 because I don't know 256. So 256 minus the 192 minus 192 here is equal. So 256 minus 192, 256 minus 192 is 64. So 64. So the new ID, new ID, new network ID, will be copy view 192.168.5.04, then view, then it will be 64. So because of this, sunod copy, so view, so 64 plus 64 equals 128. So 128 here, then view, then it will be 192 because 128 plus 64 equals 192. So we go back to the, so the Pearl's full subnet range will be 192.168.450 here because of this and this. Then next is the second will be 64, this 164, then the last will be 192. Okay, so it is correct. Then then we go to, so I So I make another network ID, and we will do it now. So this is the default address classes, the class A, class B, and class C. So this is the new network ID. So it is 192. So I write a step. That's why we can easily do the activity. So step 1, determine the default subnet mask. So the network ID is 192. The first octet is 192. So it will be it will go to class C because the first octet is range is 192. So the default mask that we will use is 255.255.255 here. Okay, tab, view. Okay. Okay, next, break out the available bits. So by doing this, we will convert it to to binary. So this subnet mask. Okay, it will be 1111111124681 1111111124681 1111111124681 then 1234567 8. Okay, so step 3, figure out the number of all the bits needed to represent 40 hosts. So we will copy it here and paste it here, view. So the 0 here represent the host. So we need to find a number that will be equal to 40. So we will copy this, move it here. Okay. Oh. Okay. $40. So it will be so we need to find a number that will be equal to 40. So it will be 32. It will 32 plus 0 here, then 32 plus 8 equals 40. So the remaining will be 0 0. Okay, so it is 1 2 3 4 5 6 bits. So these bits will be a host, while the remaining bits, which is this and this, will be joined to the subnet bits. Okay, so it will be convert as 11000000. So step 4, so figure out the new subnet mask. So the new subnet mask will be this, copy, then we will copy this because it is dahil ito kasama rin ng subnet mask. Okay, 2467, it's called labes. So we will convert it into the decimal. So it will be 255.255.255.128 plus 9 plus 64 equals 192. Okay, slash 26. Okay, we go to step 5, figure out the new number IDs. So the new number IDs will be, so it will be 256 minus 1 minus 192 192 this 192 is equals to 64. 64. So so the new ID will be so the new network ID will be copy view, so it will be 0, then view 64, then 128, then 192. So this is the new network ID. So we go to step 6, figure out the range of addresses of the new network. So by doing that, we need to copy the 192 here. Okay, view, so it will be 64 because 0 64 0 64. So by getting the range, so the upper network ID will be +1, while the lower network ID will be -2. So the range will be 192.168.10.1 because 0 plus 1 equals 1. Then 192 excuse me, 168.10.62. 64 minus 2 equals 62. 6. Okay, so that's all. So this is the all activity in this chapter. So see you in my next video, and bye bye.